Hello everyone, Professor Vaibhav Shah here. I have designed complete lecture series on engineering scales, both plane scale as well as diagonal scale, containing 15 plus examples just for you. Here the uniqueness is that each of the example is different in a manner of its technique and logic which is implemented. I tried to solve all the possible cases of scales that can be asked. So your task is to just go through all the lecture containing different cases turn by turn. I guarantee you, after studying all the lectures, there can be no example that you will feel difficult in solving. In today's lecture 1, we will start with some basic concepts of scales like why we actually need these scales, types of scales, representative fraction, or we can just say RF, unit conversion table, complete understanding of plane scale with help of graphical representation, and later we'll be solving example on that. If you like my content and teaching style, then share it with your friends, and also do not forget to like and subscribe to show your love and support. Let's begin. First, why is scale needed? So it is not always possible to draw any object directly in drawing sheet or drawing paper with its actual dimensions. Most of the times we have to either reduce its actual dimension like in case of world maps, or we need to enlarge its dimensions while in case of wristwatch component drawing. So in order to fit the drawing in sheet as well as for better visibility and understanding, we need to take any suitable scale. Now, what are the types of scales? So the types of scales can be divided into three categories. First, based on representative factor. Second, based on usage or its application. Third, based on precision of measurement and accuracy. So let us start with the first one, based on representative factor. So it can be divided into full scale, reduced scale, and enlarged scale. Next, based on usage or its application, so it can be further divided into mechanical engineer scale, architect scale, civil engineer scale. Next, based on precision of measurement and accuracy. So we can divide it into 6 types: plane scale, diagonal scale, comparative scale, vernier scale, scale of chords, and isometric scale. In this lecture, we will just only focus on plane scale and diagonal scale. So in this lecture series, we will be focusing on plane scale and diagonal scale. Vernier scale you have studied in 11th and 12th standard, and isometric scale will be covered in later sections. So now let us start first with representative fraction, or you can say RF. Now representative fraction means, in simple words, while representing any object in drawing sheet, you need to use some kind of fraction or factor, which is also known as scaling factor. So it is nothing but your representative fraction. So whenever you are representing any drawing in your drawing sheet, object in your drawing sheet, you will be using one kind of factor or fraction. So it is known as your representative fraction. Now, let us understand it more clear by its technical definition. So definition, it is the ratio of size of object in drawing to the actual size of object. It is the ratio of size of object in drawing or drawing sheet to the actual size of the object, means your real object. Now it is unitless quantity, and we will be always converting the ratio into the lowest possible unit for making it unitless. So let us start. So now mathematically it can be defined as representative factor RF equal to size of object in drawing upon actual size of object. So let us understand it by one example. So for example, when a 1 centimeter long line in a drawing represents 1 meter length of the object. So here we are having one object with 1 meter length, and we have to represent this object in our drawing sheet by 1 centimeter long line. So how can we define the RF? So let us see. So RF is equal to, now we'll put the values in this equation, size of object in drawing. So RF is equal to size of object in drawing. So what is the size of object in drawing? So 1 centimeter long line in a drawing. That means in a drawing we will be using 1 centimeter. So size of object in drawing is nothing but your 1 centimeter. To put 1 centimeter here. Next, actual size of the object. So represents 1 meter length of the object. So our actual object is of 1 meter length. That means our actual size must be 1 meter. So let us put 1 meter here. Now we have 2 units. Now it is a ratio. Now here we say that ratio will be converted into lowest possible unit. So let us check. We have 2 units, centimeter and meter. So it is obvious that centimeter is the lowest unit. So we'll try to convert this meter term into our centimeter. So now we know that 1 meter is equal to 100 centimeter. We'll just put in the place of this meter 100 centimeter. Now centimeter centimeter cut. So we can have finally the ratio 1 by 100, which is nothing but your required representation factor. So this can be represented by RF is equal to 1 is to 100. So either you can represent it by 1 by 100, 1 divided by 100, or RF can be represented by other terms. RF is equal to 1 is to 100. So this was your representative factor. Now next. Now types of scales based on the representative factor. So we have defined this representative factor just previously. So we'll divide these types of scale based on that representative factor. So what are the types? First, reduced scale. Second, enlarged scale. And third, full scale. So first let us see reduced scale. So reduced scale means your scale showing 1 is to 2, 1 is to 20, 1 is to 200, 1 is to 2000, 1 is to 5, 1 is to 50, 1 is to 500, 1 is to 5000, like 1 is to 10, 1 is to 100, 1 is to 1000, or 1 is to 10,000. So these are all examples of your reduced scale. Next, enlarged scale. So 50 is to 1, 5 is to 1, 20 is to 1, 2 is to 1, 10 is to 1. So these are the examples of your enlarged scale. Now full scale. So 1 is to 1 is the example of full scale. So now as we can witness from these examples that 1 is to x is the form for this reduced scale where x is greater than 1. So now from these examples we can observe that 1 is to x is the form for reduced scale where x is greater than your 1. So check 1 is to x, 1 is to x, 1 is to x, and here in each of the cases x is greater than 1 obviously. So this is your reduced scale. Similarly, from the example of this enlarged scale we can say that x is to 1 is the form of your enlarged scale where x is greater than 1. So let us check. X is to 1, x is to 1, x is to 1, x is to 1. So this is nothing but your enlarged scale. So now you will ask, sir, it is very easy to understand, sir, but in examination we always get confused. So how to remember this in an easy way? So I will teach you one easy way. So now it is very difficult sometimes when in examination it is asked that what is the scale 1 is to 2? It is a reduced scale or enlarged scale. So you will get confused between 1:2 and 2:1, because in examination, in exam pressure, we get confused. So let us solve this confusion by easy manner. So we'll always replace that is to sign by division sign. So try to replace each of the is to sign by division sign. So if we try to replace it by division sign, we will get answer 1 by 2, 1 by 20, 1 by 200, 1 by 2000. So if you try to get answer by your calculator, you will be having this answer in 0.00 something, 0.00, 0.00, 0.000, something like this. That means your answer would be always less than 0. So if your answer is always less than 0, then it is a reduced scale. Your answer is reduced than 0. Your answer is reduced than 1. So your answer is less than 1. So you will be having this reduced scale. This answer would be less than 1. 1 by 2 is your 0.5, which is less than 1. That means it is your reduced scale, obviously. Now, if we put division sign here, 50:1, 5:1, 20:1, 2:1, so answer would be 50. 50 divided by 1, so you will be getting 50. 5 divided by 1, you will be getting 5 answer. 20 divided by 1, you will be getting 20 answer. 2 divided by 1, you will be getting 2 as answer. So that means your answer is far more than your 1. So that means it is your enlarged scale. That means you are getting 50 answer. That means you are multiplying your drawing size by 50 times. Here 5 by 1, that means you are getting 5. That means you are drawing your object 5 times larger than your actual object. So that means this scale would be definitely your enlarged scale. And full scale means whenever you are drawing the actual object in the same dimension in your drawing sheet, like same dimension, you will be having 1:1. So these were your 3 types of scale based on your RF. Next, now we will be using the following formulas for our calculation of this topic. So first, A, representative factor, RF, equal to dimension of drawing upon dimension of an object, actual object. Next, if your dimension is specified in the terms of length, so it will just change a bit. So length of a drawing upon actual length. If your data, it is given that area of a drawing, so it will change a bit, like under root of area of drawing upon actual area of an object. If it is given in your example volume of a drawing, so you will be taking cube root. In cube root, you will write volume as per drawing upon actual volume of an object. So these are your important equations. You have to memorize this equation. If you can memorize this equation, I guarantee you, you will not suffer with finding out the RF, which is the first step of solving any of the examples. Now, you require one more equation, which is length of scale, which is equal to RF, which we can get from this first equation, into maximum length to be measured. So in examination, each of the examination, it must be clarified that how much maximum length you need to measure. So you will just put that data here. So you will get your length of scale, which we will be using to draw our object in our drawing sheet. So this will be the length of your scale, which we will be using as our drawing in your drawing sheet. So it must be always in your centimeters, because we'll be drawing in our drawing sheet by our centimeter scale. So we'll be having this length of scale. So you have to remember this A and B, and from that we can solve our examples. Next thing to remember is unit conversion table. You have to memorize this unit conversion table by any way to have complete understanding of any of the examples. So let us see the unit conversion table. So this is our unit conversion table. This is an exhaustive table. So we will have most of your example from this table itself. If you can try to remember this table, you can solve any of the examples. First, 1000 millimeters or is equal to 1 meter. 100 centimeter is equal to 1 meter. 10 decimeter is equal to 1 meter. 1 decameter is equal to 10 meters. 1 hectometer is equal to 100 meter. 1 kilometer is equal to 1000 meters. 1.609 kilometers is equal to 1 mile. 1 yard is equal to 3 feet. 1 foot is equal to 12 inches. 1 inch is equal to 2.54 centimeters, 1 nautical mile is equal to 1852 meters, 1 meter is equal to 1.0936 yards. So I will insist that previous two equations as well as unit conversion table, try to write down on one blank paper and try to memorize each day to get it memorized. Now, after this unit conversion table, you will say, sir, it is very difficult to memorize each of the terms. So how can we memorize in an easy way? So let me give you one example or trick. So now here we have to convert 1 kilometer into meters. So how to convert? So you'll be using this staircase to convert any of the units. So if we go up in this staircase, so we'll try to divide our figure by 10, and if we just decline from this staircase, we'll multiply by 10. So now suppose our base unit is meter. So this is a meter and this is kilometer. So now we have to go from kilometer to meter. So we'll start from this kilometer. You can see one cat here. So now cat needs to step down by 3 steps to reach this base unit. So now this is your kilometer. So this is your 1 kilometer. Now we want to step down to meter. So how many steps you need to decline? So 1, 2, and third step you are having your shoe back. So now you have to decline by 3 stairs. So just each of the stairs contain 10 and we are declining downwards direction. So we will multiply it by 10. So now we have total 3 steps, 1, 2 and 3. So now 1 kilometer is equal to 3 steps, 10 into 10 into 10. So that means 1000 and we will finally reach our base unit which is meter. So our answer would be 1 kilometer is equal to 1000. So once again we have to stay back from your kilometer to your base unit. So now from kilometer to base unit you have to decline by 3 steps, 1, 2 and 3. Each of the step contains 10, 10, 10 and 10. So we will have to pass from 10 steps, 10, 10 and 10. So now if we are declining, so we'll be multiplying your unit by 10. So we will be multiplying 3 times 10, 10 into 10 into 10. So we'll be having total 1000 meter. You can try for another units so you can easily memorize this table. So now let us move ahead. Now plane scale, which is our first topic of understanding, plane scale. So now let us understand the definition. It is nothing but a straight line divided into suitable number of equal parts or units, the first unit of which is further subdivided. So now let us understand it by your graphical representation. So it is nothing but a straight line. So you can see the straight line divided into suitable number of equal parts, 1, 2, 3, 4, 5, 6 number of parts, the first unit of which is further subdivided. So you can see the first unit is further subdivided into 10 parts. So it is nothing but your straight line. So it is nothing but a straight line divided into suitable number of equal divisions, first unit of which is further subdivided. Now plane scale represents a unit and its fraction up to 1 decimal place. That means here from our example 4.6. So this is your unit 4. Decimal place means after point you are having only one digit. That means only one decimal place. So this is your one decimal place. This is your answer with one decimal place. Unit and one decimal place. So plane scale represents a unit and its fraction up to one decimal place only. So as you can see, we can denote only 4.6 meters. Now it can measure between two interconnected units. So as you can see, we can measure between meters and decimeters. So it can measure between two interconnected units like its units and its tenths. We can measure between unit and its tenths. So this is your unit and after a point you will be having its tenths. Now representation of scale with its features. So how to represent the scale? So plane scale consists of the line divided into suitable number of equal units called as primary units. So this is your line divided into suitable number of equal units called primary units like 0, 1, 2, 3, 4, 5. So 0 to 5 are your primary units. or your main unit. So main unit is your meter. So before your decimal place 4, so we'll be defining by meter. Now further subdivided into the first unit is further subdivided into smaller parts or a second unit. So this for first unit is subdivided into smaller parts or subdivisions. These are known as your secondary unit. So this is your secondary unit, decimeter here. Now 0 should be placed at the end of the first unit. So this is your first unit, so we'll be placing always 0 after this first unit here. So this is your first unit, so we'll be placing 0 somewhere here. Now from 0, mark the main unit should be marked from 0 mark. The main unit should be numbered to the right on main or primary scale. So from 0 mark, we'll be placing the main units on the right hand side direction on the main or primary scale, and subdivisions to the left on the secondary scale. So from your 0 mark, subdivision should be placed on the left on your secondary scale. So we are having two scales. From your 0, on the right hand side, it would be a primary scale or a main scale. From 0 onto its left hand side, we'll be having one subdivision scale or a secondary scale. So the units which indicated on primary scale are known as your primary units, and units which are indicated on your secondary scale are known as your secondary units. Here primary unit is meters and secondary unit is decimeter. Now the units and subdivisions should be labeled correctly. So always remember that you will write down your sub unit just below your subdivisions. You will be writing down your primary unit at the center of your primary scale from 0 to 5. You will draw your, you will write down your meters in the center point of your 0 to 5, which is 2.5 here, and you will always specify your RF on the right hand side of your scale. You will always specify like this. So this was the general understanding. So let us take one example of this scale. So now draw a scale. 1 centimeter is equal to 1 meter to read decimeters and to measure maximum distance of 6 meter. Show on it a distance of 4 meter and 6 decimeter. So here the scale is given. So whenever your scale is given, you will convert first it into RF. You have to read decimeters. You will be making scale of decimeters. Maximum distance that you have to measure is 6 meter. So you will be constructing the scale of 6 meter, and on that scale, after construction of that scale, you will be measuring the distance of 4 meter and 6 decimeter. So let us start. First, we'll be calculating RF from our given scale. So RF is equal to dimension of a drawing upon dimension of an object, actual object. So our dimension of a drawing is 1 centimeter and dimension of object is 1 meter. So we'll be dividing 1 centimeter by 1 meter. Now next step, we'll be converting units into lowermost units. So this is meter, this is centimeter. So we'll be converting this meter into centimeter, which is the lowest unit. So we know that 1 centimeter divided by 1 meter, we'll be replacing it by 100 centimeter, because 1 meter is equal to 100 centimeter. So replace it by 100 centimeter. Centimeter cut. So we'll be having 1 by 100 as our RF. After that, we'll be using our second equation, actual length of scale is equal to RF into maximum distance. So here our RF is 1 by 100. Maximum distance is asked as maximum distance of 6 meters. So you have to put this 6 meter here. So you'll be multiplying 1 by 100 into 6 meter. But if we multiply it directly, so we'll be getting answer in meters, but we don't have meter scale to draw in our examination. We'll be using with our ordinary centimeter scale. So we don't need here meter. So we'll try to convert this meter always in centimeters. So now we'll convert these meters into centimeter first. So 1 by 100 into 6. And now we'll be converting 1 meter is equal to 100 centimeter. So put 100 centimeter here. So now if you try to solve this equation, you will have 6 centimeters as your answer. So you will be drawing the actual length of scale in your drawing paper as 6 centimeter, which will represent your 6 meter scale. So now we'll start. So first you will draw one line with your answer, which is actual length of scale 6 centimeters. So first you will draw one line of 6 centimeters length. After that, you will divide this 6 centimeters line into, we have to measure maximum distance of 6 meters. So here we'll always take the divisions from your maximum distance. So maximum distance will check for the significant digits. So your significant digit is only 1, which is 6. So So we will always divide this line based on the maximum distance. So here maximum distance is 6. That's why we will be dividing this line into 6 equal parts. So you have to compulsorily divide this line into 6 equal parts. Let us divide this line into 6 equal parts. So I have divided this line into 6 equal parts. After that, let us start numbering from your first division endpoint, mark 0. So you will just omit this first division and you will mark 0 at the end of your first division. So I have marked 0 here. Now from 0 on your main or primary scale, you will write down 1, 2, 3, 4, 5. So you will always have one digit less than your actual digit. So which is we are constructing 6-meter scale, but we will be having always one digit less. So here it is 5. Now after that, you will give subdivision on the left of your 0. So you will be dividing this into 10 equal parts, which is the subdivision of this line. So you are dividing this into subdivisions. Now after that, let us give these notations. So this is your primary scale, so you will be writing it as a primary unit, which is meter. Now this is your secondary scale, so it is a 1 unit lower than your meter, which is your decimeter. So when you divide 1 meter into 10 parts, so you will be having this new unit as a subdivision, which is known as your decimeters. After that, we'll be writing down here RF, as I have said earlier. So now let us define our final distance, which is 4 meter and 6 decimeter. So now how to define? So we will measure always 4 meter, which is your primary unit, and 6 decimeter, which is your secondary unit. So 4 meters, so let us try to measure from this 0. So 0, 1, 2, 3 and 4. So we'll be drawing one vertical line from 4. And secondly, we have to measure 6 decimeters. So from 0, we will be going on the left hand side on this secondary scale, 1, 2, 3, 4, 5 and 6. From this, you have to draw one vertical line. After drawing your vertical line, you just join, you will be having 4 meters and 6 decimeters. So always remember, you will be marking 0 after your first division. From this 0 on the leftward direction, you will be marking this decimeters or secondary units, and from 0 towards the rightward direction, you will always specify your primary unit. Now you will be drawing one vertical line from two of the ends. This vertical line can be either of 5 mm or 10 mm. I will suggest always draw this 10 mm vertical line and try to complete this rectangle. After completing rectangle, now we'll specify units here, decimeters, meters and RF. And after that, we'll try to measure, which is given distance 4 meter and 6 decimeter you have to indicate. So we'll start from 0 on the primary scale, 1, 2, 3, 4, draw vertical line. And on the secondary scale, we have to measure 6 decimeters, so 0, 1, 2, 3, 4, 5, 6, draw one vertical line, and this is nothing but your required distance. Next, remember, to construct the scale, the data required is number 1, the RF of the scale. Number 2, the units which it has to represent, like millimeters, centimeters, meters or kilometers in MKs, or inches, feet, yards, miles in FPS. Number 3, the maximum length which it should measure. If the maximum length is not given, some suitable length can be assumed. Number 4, actual length of scale to be constructed on a drawing sheet. So which you can get from this equation, actual length is equal to RF into maximum length to be measured by scale. So that is all from my side.